Gravitational potential energy made easy. GCSE Physics. That was the most powerful weapon humans have ever built. The Tsar Bomba. It released enough energy to flatten a whole city. What does that have to do with an elephant in a tree? An African elephant. A real one. 6,000 kilograms of living animal. Now, imagine it's 5 meters up, at the top of that tree. If it fell, it wouldn't bounce. It would release a terrifying 300,000 joules of energy in an instant. But what is a joule? A joule is just the standard packet of energy. Lifting this apple 1 meter against gravity, that takes about 1 joule. So our elephant in the tree might look like it's just sitting there, but actually, it's storing the energy equivalent of lifting up 300,000 apples. What's difficult to understand is this. That energy was already there, before it fell. It's stored, waiting. We call it gravitational potential energy. But the moment it starts to fall, that stored energy transforms. It becomes kinetic energy, the energy of movement. The higher it was, the more stored energy it has to turn into movement. Think of it as an energy loan. The universe stores energy in anything that's been lifted against gravity's pull. And there are 3 things that decide the size of that loan. 1. How heavy is it? The mass. For example, a lorry with a mass of 40,000 kilograms. That elephant, 6,000 kilograms. You, about 80 kilograms. Or maybe your phone, 0.2 kilograms. The second thing we need to know is, how high is it? The height. 3. How strong is the pull? This is gravitational field strength. It is measured in newtons per kilogram. On Earth, it's roughly 10 newtons for every kilogram. We call it G. On the Moon, there's a weaker gravitational field strength, a weaker pull of gravity, and therefore a lower G. Less energy gets stored. On Jupiter, stronger G, a lot more energy gets stored. Put them together and you get the equation. Energy equals mass multiplied by gravity, multiplied by height. E equals mgh. Let's calculate. The elephant. Mass is 6,000 kilograms. Gravity is 10 newtons per kilogram. Height is 5 meters. 6,000 times 10 times 5. 300,000 joules of energy is stored, just for being up a tree. So if it fell, all that potential energy rushes into motion, into kinetic energy. The result? The elephant's bones would shatter on impact. The ground wouldn't just be dented, it would be cratered. That's 300,000 joules of stored energy hitting the ground in a split second. Now, your phone. You're on a trampoline. It's in your pocket. You jump half a metre high. Mass, 0.2 kilograms. Gravity, 10 newtons per kilogram. Height, 0.5 metres. 0.2 times 10 times 0.5. 1 joule. Sounds tiny. That's just 1 apple's worth of stored energy. But when it falls, that 1 joule of potential becomes 1 joule of kinetic energy, of motion, right before it hits. Enough to crack the screen when it hits the trampoline mat. The energy never disappears, it just changes form. From stored potential to kinetic. From the 1 joule that cracks your screen to the 300,000 joules that would destroy an elephant and crater the Earth. to the 200 trillion joules, 200 trillion times more, of a nuclear blast. The principle is the same. Grab the gravitational potential energy resources using the link in the comments or link in bio. Now also includes the practice workbook. Be sure to watch the next video about one of the fastest objects to ever hit Earth and find out what that has got to do with kinetic energy.